the wrong thing. All right, let's let that load up here. So you know from flying that the plane, we'll just use a plane instead of a boat, it has some velocity, some rate that it's moving at. Okay. And if the wind is helping you, what does that mean? Like in terms of like how fast you get somewhere?
Well, speaking aviation terms, you have a lower fuel burn because you're more efficient. So, but if you're maintaining the same, airspeed, then you're going to go significantly faster.
That's right. That's right. And then you get the other way around, which is if you're going against the wind, it hurts you. I mean, and you see this all the time. Like I've flown from Tucson to Denver, and going there is really fast, and coming back is not as fast. And you're right. There's other variables in play, like you mentioned fuel burn. But if we could assume the engines are if it's the same velocity and the wind is impacting it, and that's what they're talking about here. There's the upstream and the downstream equation, or the upwind and the downwind and then the upwind equation. But these are all, I mean, these are all in the category of distance equals rate times time. It's just that these are your rates. Your rates are either with the wind or against the wind.
Gotcha.
Okay, so we do you typically go through the examples in the classroom?
Yes. Well, yeah, I'd say usually.
Okay.
I think.
So we're just going to jump right to number 1 in the new problem set. Is that okay with you?
Yep. Or do you mean like example or just the problem?
The problem, actually problem. That might be more useful to you, unless you've already done this.
No, I have not.
Okay. All right. So Alonzo, okay, we don't care. The two people go 70 miles downstream. So that's the D is 70 miles. In the same time, it took them to go 30 miles upstream. Okay. If the speed of their boat was 10 miles per hour in still water, what was the speed of the current and what were their times? Just as an aside here, I'm reading a new book on the 1927 flood of, what is it? It's the Mississippi River that flooded, but it was New Orleans that flooded real bad. There's this whole debate on levees versus what's the other one? Anyway, it's really interesting. We don't know that much about rivers the way we think we do. The Mississippi is believed to actually travel about 10 miles per hour. The water in it is moving pretty fast, which is, you just look at it, you're like, it's not moving that fast. It's 10 miles. It's actually moving quite fast. So just an aside there. But this problem here, you typically look at, you've got the downstream, and then the upstream. And you're always starting out with D equals RT. Okay. And I don't use all the subscripts because I don't think you need those, but it's 70 miles downstream. And what is the rate? So downstream means it's helping you. It's your rate plus the rate of the water. And so it's 10 plus W in this example. And we don't know how long it took, but call that T.
Okay.
You do the same thing for upstream. Okay, D equals RT, and 30 miles per hour. This time, though, the water is hurting you, so 10 minus W times T.
Okay.
All right, now the nice thing here is you have two equations and two unknowns. So in principle, you know how to solve this. You have some method here using elimination, substitution, and that's where you have to kind of decide what's best here for you. I'm going to distribute the T to both. So it's 10T plus WT. And then I'm going to do the same thing over here, but I'm going to write the result on the left, 10T minus WT. Now you kind of have to look ahead to do these problems. You have to kind of get a feel for what's going to happen, which I know is very hard as a math student seeing this for the first time. But the more you can kind of peek around the corner, what's going on, it hints at what you should do, which is to add these equations together.
Mhm.
okay, because the
So it'll
WTs
be,
cancel.
yeah,
Because you're looking for something
yeah.
to cancel. Cancellations are huge.
So it'll be 100 equals 10t, which equals
20,
basically 10 equals
20,
t.
20T.
20, sorry. So 5 equals t.
Yes. Now your book's very good at oftentimes asking you for more than just like this, or this isn't even part of the answer. We know that it takes 5 hours. And the reason we know it's in hours is because the rate is in miles per hour, mph. Okay. And then
Mhm.
you need to use one equation or the other to find the W. Doesn't really matter. You pick the one you like more. I don't know if you like the one on the right or the left more, but you just pick one and get the
Okay.
value W. So will you do that for us, please?
Yes.
I'm sorry, value of yes, yeah, W, sorry.
Is that 4 equals w?
Yes.
Okay.
All right, now some reasonableness things here. Typically the speed of the water is less than the boat. Because if
Yeah.
it wasn't, it would be moving backwards. So there's some reasonableness there to your answers. So any questions on that?
No.
Okay, we'll do another problem here. What kind of wind speeds do you see in the air?
Well, our plane's cruising speed is around 140 knots, which is maybe 160, 170 miles per hour. So
Okay.
yeah.
What's the airspeed again, what's like the velocity of the air in knots or some
Hmm.
what would it be?
Well, let's see. Let's say it's a very windy day, barely flyable. That would be maybe 20 knots. And so that's maybe like 25 miles per hour. That's probably the most that a skilled pilot can handle in our plane.
Okay, I see. So yeah, I mean, there's a
Yeah.
lot of days where it's not good enough to be able to, or it's too
Yeah.
windy. I see.
At least in a small plane like ours,
Sure.
it's
Yeah.
it only has room for 4 people, so definitely can't fit it's not designed to go through super, a large amount of wind.
Got it. Got it.
Yeah.
Okay. So the previous problem, they gave you, if you notice like what the givens were, they gave you distance and they gave you the rate. They have to give you two of the three. This time they give you the distance and the times. So they're
Okay.
typically always going to give you two of the three or enough information for two of the three. And you just split them apart into down and up. So go ahead and see if you can write the equations for this. I'm going to step away for 30 seconds and check back once and see how you're doing on that. I'll be right back.
Yeah.
All right, I am back. Let me know if you've got either of these equations.
Okay. All right. So downstream, 15 miles per hour, and then upstream 11.
I'm looking for something in this form.
Okay. So
I'm
I
looking
got
for something
60
equals
equals
something.
R4, and then 55 equals R5.
Okay, so I see you're using subscripts. You want to think of the rate as being rate plus W
Oh,
and
gotcha.
R
Gotcha.
minus W. Like this is the more standard way to do it. Not
Hmm.
using these subscripts, at least not in this course. I mean, Saxon uses them, but so here's what I was looking for. Something like R plus W times 4. That's what I was looking for.
Okay. Gotcha. All right. So then that'd be 55 equals r plus w, or sorry, r minus w times
Good.
5.
Good. Okay, now in the previous problem, we distributed the 4. Okay, but I mentioned that's not, you kind of need to look ahead. So if you distribute the 4 and you distribute the 5, there won't be any cancellations because you'll have 4r and 4w, 5r and minus 5w. So you want to do something different here. And that's almost as much a part of this as like, what is the right method to solve this? So you don't see this often, but you want to actually divide by 4 and divide by 5.
Okay.
So 15 equals r plus w, 11 equals r minus w.
All right. So then you would add them.
Yes. And by adding them, you see that there's a cancellation.
So r equals 13.
Yes. What are the units of r in this problem?
Miles per hour.
Okay. And then w would be 2. You can use either equation. Sometimes you can just do it by inspection, just kind of looking at it. They call it mental math, but
Yeah.
you actually are substituting in, subtracting. These are reasonable. Like one of the things I do like about your book though is they do give you reasonableness. Like 2 miles per hour in a gentle stream is probably pretty reasonable.
Yeah, I've heard well, we've all seen the memes about, the crazy math questions like, you know, Johnny ate 500 watermelons in a day or
Yeah,
something like that.
yeah. Yeah, I actually wrote I wrote a bunch of questions in software that I put up on my website for the question of the week, and that was a point of emphasis, was to try to map reasonableness, and it's much harder than you think. I mean, it's a lot easier actually now with like AI and stuff like that, but from a programming perspective, it's like you like one of the problems that comes to mind is I had an earthquake problem, and that's like it was like an inspector from Iran, and I'm like, well, that's probably not really realistic right now. Um, so,
Yeah.
but what we did is we just grabbed a bunch of data sets and we just started throwing them together, and we found out that you have to really subtract these data sets down to very few possibilities. And but what's nice here is these are reasonable, like 13 and 2 would be fine, 14 and 3, but not 14 and 25 miles per hour for wind. Like we said, you wouldn't expect the wind to be
Yeah.
faster.
Yeah, exactly.
All right, so I think we can do one more here on the same grouping.
Yeah.
Actually, this would be a good one for you to try on your own.
Yeah.
Ask questions if you're not sure. I recommend the same approach. I can't say that it's exactly the same, but I don't know. I feel like if I just do another one here, you may not get as much out of it as trying one here. So let me know what
Yeah.
you come up with.
All right.
Any questions on this one?
So t equals 3. Just trying to find r. Try to substituting it, but I usually get an answer of 0. Okay. R.
Tell me your setup here, right? Tell me what equations you
Okay.
wrote.
So I wrote 21 equals r plus 7 times t.
Okay.
Yeah.
Good.
And
And
then 35 equals parentheses r minus 7 times t.
okay.
All right.
So this one's different, right? Like all of a sudden it's like, they didn't give us t this time. Your choice here really is, are you going to multiply by t or are you going to divide by t? And one thing I see right away, when you multiply the t in, you get tr minus 7t, tr plus some t. You might, oh, that's great, I'll just add them together. Problem is the tr cancels. So this one, and maybe that wasn't fair to you. This is one where you have to solve for t in both. Now, I do think t equals 3 is correct. So I'm still kind of struggling with why this isn't working out, but let's just keep going here. So t, and this one on the right here is 21 over r plus 7. And one on the right here, t equals 35 over r minus 7. So you set those equal to each other. 21 over r plus 7 equals 35 over r minus 7. Okay, why don't you solve that from here and see what you come up with. Wait a second. I may have given you one here that I may have done something wrong here.
Okay.
Maybe that's why you had, okay, 7 per hour speed. We can go 21 kilometers upstream. Okay, there it is. We've got the wrong numbers here. It should be 35 upstream. I'm sorry, 35 down, and then the other one here. That's what causing this problem, which will switch the numbers here. And now it will actually have a solution. Okay, so try that. See if you come up with something a little better. Let me know if you've got an answer.
Yep. Okay, r equals 28.
Yes. So R is 28. Where does that leave us with T? And sometimes that's
Yep.
so yeah, I'd go back to one equation or the other. See what you come up with.
Yep. Okay. Again, just to make sure.
Any
The
trouble?
oh good.
Go. I was going to ask you what you came up with.
Um. Okay, so is this gonna be t equals? This is probably way up. 735.
Did you use which equation did you use? This first one on the left or this one on the right?
I use the one on the right.
Okay, so simply put here, it's 21 equals 28 minus 7 times t. Is that what you have?
Let's see. Oh, whoops! I forgot to write the t there. Oh, okay. I just copied it. Sorry. Let's see. That's why I was having problems. Okay, so 1 equals t, but then
Yes.
okay, it's not 735.
Yeah, I mean that's where you go with your reasonableness. Like could it take an hour to
Yeah.
go this long? There's so many bad math problems out there. It's like maybe we get confused like that, but your times should generally, we'll just say, should be like from 0 to say 20, and your rates should be like 0 to 30 maybe. But what's
Mhm.
nice here, here's what's nice thing, and I actually really like your book for this. We've done the 3 types of problems you'll see. You will not see a different type of problem than this. Like if you go to your next chapter in your book, or I'm sorry, next section, and you look for another 92, you will see one of these 3 types of problems.
Yeah.
Right. Okay. Do you want us to go on to the discriminant? Do you want us to work on some problems in the rest of that homework assignment there for problem set 92? What would be best
Yeah. Yeah,
for
that'd
you?
probably be handy. I'll be doing this Monday, so might as well get get all figured out before then. So
Okay.
I
So
guess
the
6 and
discriminant.
7. Yeah.
Okay. All right. So the quadratic formula comes from ax squared plus bx plus c equals 0. And there's so you get a bunch of problems like this, and then the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. You know that, you've seen that, I think, before.
Yeah.
All right. Now there's like 3 possibilities for what's called the discriminant. The discriminant is the part under the square root. Okay, so there's 3 possibilities. It could be greater than 0, it could equal 0, or it could be less than 0.
So it could be any number.
It could be anything. Yeah. Now this leads to, and so there's sort of like 3 main cases, and then there's sub cases. Let me just look at your notes and see what they, yeah. Okay. So I don't think, I'll just do it even if you don't see this in class. So case 1 is the discriminant is greater than 0. Okay. So the sub case here is that the discriminant is a perfect square. Okay. So what do I mean by that? It ends up being like 1, 4, 9, 16, so on.
Mhm.
And what that does is this produces 2 real rational solutions.
Yep.
You'll see in books they'll sometimes just say real, I'm adding this rational part. The other subcase is that D is not a perfect square. Okay, so like that would be 3, because that leads to the square root of 3 or 5, square root of 5. You still get 2 real solutions. This time, though, they're irrational.
Okay.
So I'm just adding in this irrational business, but typically they want you to know there's 2 real solutions. Okay.
Mhm.
Case 2. Case 2 is that the discriminant equals 0. This gives you a single, one real rational root, but it's repeated. Okay, so it's the case here graphically where the quadratic hits the x-axis or comes up and hits the x-axis. It's real, it's rational, meaning it's a fraction or it's a nice number like that. And then case 3 is a lot like case 1. Okay, it depends on whether the part that's not negative. So like you could get something now like -16, -25, -36. If you exclude the negative, you just look at the number, you end up getting a nice complex number. Okay, you get, and this isn't really the right language, but it's a I'll just write it that way. Nice complex number. Okay, with an I in it. So an example would be like 1 ± 2i over 2. Like that's kind of a nice complex number versus a not nice, because you can't use words like rational, irrational, because you're in the complex domain. So we'll say an enemy complex number here. And the example would be something like 1 ± the square root of 3 times I over 2. Okay. Basically, the difference is, do you have a root or not? And all of this is dictated based on that b squared minus 4 AC.
Yep.
All right. So this one's like very programmatic, very literal. I can make up problems, but we'll start with some really, very basic ones. I guess they give you those. Do you want to read off any of the ones from 93 that are in your assignment there?
Okay. So just any in particular?
Yeah, just read
I guess
the
we have to.
quadratic. Yeah.
Okay. X squared equals -5x plus 1.
Like that. Is that correct? Go just the one's fine for now.
Yeah.
Okay.
Okay.
So first thing here that actually we kind of have to back up is it has to be in the form ax squared plus bx plus c equals 0. Basically, we need to have a 0 on the right-hand side. Okay. So that means you're going to manipulate this equation. Plus 5x minus 1 equals 0. Is that okay?
Yep.
All right, now the next thing is to identify A, B, and C. Can you tell me the values of A, B, and C?
Yes. A is going to be 1.
Okay.
B will be 5, and then C will be -1.
All right, so I want you to very carefully calculate b squared minus 4ac. You may find that it's smart, a good idea here to put the values you're substituting for in parentheses. You may find that will eliminate the possibility of some sign errors later on.
So that will equal 29.
Yes. Okay. So that means it's the square root of 29. So first thing is we know that it's positive. Okay. 29 is positive. So that means there's 2 real roots. But are they rational or irrational? Basically, I'm asking you, can you take the square root of 29?
No, so
No,
it'll be irrational.
irrational, yeah. Rational is just a nice way of saying nice, could be a fraction, could be a decimal that repeats. Irrational is not that.
Gotcha. Do you hear the wind and the rain?
I cannot hear that. No, the microphones are
Okay, I'm
actually
in
really
the
good.
huh,
Do you need to
lovely.
adjust? Do you need to adjust?
Oh no, I was just saying that I'm in the garage, and so it's pretty loud here, but it's good to know that you're not picking it up.
Yeah. Yeah. Now, did you celebrate yesterday, March 14th?
Oh, what was that again?
Well, it's that thing we talked about. It's that Greek letter.
Ah, I see. P, yes, March 14th. Wow.
Yeah. Now you can celebrate it today if you like to round, because no, I'm sorry. Does not
Fair
round to
enough.
March
Fair enough.
3.15. If you use 22/7, I think you can get there's some way you can get it to make today also, but yeah, it could be a big deal if you're so. All right,
Lovely.
what's another one
I'll
there?
keep that in mind for next year.
Don't get caught off guard. Um,
Yep.
all right, what other problems there can we look at?
Okay. Probably question number 7. That way,
Okay.
get that covered.
Do you have another one you can read out loud for us, please?
Oh, yes. Oh, sorry. I know I was supposed to read it. Minus 3x equals minus 2x squared minus 5.
Is this correct? Sorry, or not? Let me is this what you said?
Yes.
Okay. So you got to get everything on one side of the equal sign. So my choice will be to go left. It does not change the answer if you move to the right. I just like having that leading term positive. That's just my preference here. So we got 2x squared minus 3x plus 5 equals 0. And I want you to find b squared minus 4ac for us, please.
Okay, I got negative 31.
Okay, so we got 9 minus 4 times 2 times 5. Yes, that looks correct. So this one is two complex numbers. I said imaginary. That it's got a real and an imaginary parts. They are complex. The books generally don't distinguish between like the nice ones and not nice ones, but the idea is it's the square root of negative 31. And that's where you're going to introduce this I. You remember that from earlier in the course or other problems?
Yeah. Yeah.
I is the square root of negative 1. There is more to it than that, but that's where they leave it for you in algebra 2.
Okay. Very well.
All right, got some time left here. What else can I do for you today? How else can I help you today?
Perhaps question number 30, which is just 2, but yeah. So find x and y.
Are you referring to something you sent over?
Yes.
I don't see a question.
It has some graphs in it. Oh, you don't see it? Oh, let's see.
The ones you sent only goes up to 28. Nope, there it is. Sorry. There's 30.
Okay.
Find X and Y. Okay, yes, we can do those. This is from geometry.
Mhm.
All right. So here we go. The one on the left, I think, is more straightforward. It's called an interior angle. And it's off from the center. So there's three types of angles that you might see inside a circle. One is where it touches the center, the other one touches the outside edge, and then there's one that's just sort of floating, we'll say. And the formula
Mhm.
here is that let me actually draw the generic formula here for you. So let's call it little m, big M, and then X. So the formula here is that X equals big M, little m plus big M over 2, basically the average of the two.
All right.
So the value of M there, or X, looks like it would be 60.
20 plus. Okay.
Is that okay?
Yes.
Now, sometimes they do this. Sometimes they ask for Y, and you have to use the fact that it's X plus Y add up to 180 for that.
Ah, gotcha. Makes sense.
All right, now I'm stalling a little bit here. Do you have the formula for the two chords? Because I believe it's like 4 times Y equals 3 times 7, but I'm not sure.
Yeah, I
It,
think that's
it
probably what we'd use.
There it is. Yeah, I did find it just now. So the one on the right here, 4 times Y equals 3 times 7, 4Y equals 21. Not sure why this works. There's kind of a lot of really neat things about circles and triangles, especially, and this one I'm not really sure why it works, but a lot of drawings used to be done by hand. So there had to be a way that people could make this stuff, work out so nicely with their architecting
Yeah.
things.
Goes all back to like Euclid's geometry that I always rant about.
Mhm.
Quite elegant.
It is. It is. Okay. Any other problems here you'd like us to look at? Got a little time here. You'd like?
Um, maybe 28.
Sure. Use unit multipliers to convert 15 centimeters per second to yards per minute. 15 centimeters per second, and we're going to yards per minute. So I choose one of them. I'm going to choose centimeters first. There are 2.54 centimeters in 1 inch. And I'm going to go right to inches to yards. There are 36 inches in 1 yard. So that takes care of that top one.
Mhm.
Now we're going to deal with the bottom one. Okay, there are 60 seconds. Now notice the difference here is that instead of putting the matching unit on the bottom, I put the matching unit on the top. 60 seconds in 1 minute. Seconds cancel. And now I've got it.
Okay. So I guess I'd calculate that.
Yes.
Okay. Okay. 9.84 yards per minute.
Almost there. Yes, that sounds right. So 9.84 yards per minute. All right. I think that's going to actually do it for today. Sorry, it's asked for another question. We really wouldn't have time. So I'm going to go ahead and stop the recording here.
All right.